Welcome to this explainer. Have you ever actually stopped to wonder how the apps on our phones get updated, sometimes multiple times a single day, without the whole entire system just crashing down? Well, today, we are exploring the absolutely critical bridge that makes all of that possible. We're looking at Jenkins, often called the true pillar of DevOps and CI/CD automation, and we're going to see exactly why it's been the industry's backbone for so long. Okay, let's dive into this. For the longest time in software development, there was this massive, basically unavoidable point of friction. On one hand, you had the development team, right? And they're wanting to push out new features as fast as humanly possible. But on the other hand, you had the operations team, totally dreading the chaos that new code almost always brought with it. It was just a constant, exhausting tug of war. So the fundamental question became, how can teams reliably release software at any time without breaking everything? How do we move fast, but, safely? Section 1. The DevOps Bridge. So DevOps really stepped up as the ultimate peacemaker to stop that tug of war. And sitting right squarely at the center of that bridge is Jenkins. It was created by Kosuke Kawaguchi way back in 2004. And actually, fun fact here, it was originally called Hudson before a trademark dispute forced them to change the name. But essentially, Jenkins is an open-source automation server. Though to be honest, it's really more like a highly advanced automated traffic controller. It literally takes over all the boring, repetitive parts of the software development process, things like building, testing, and deploying code, so that human developers simply don't have to. Section 2. Demystifying CI and CD. To really get how this tool works, we kind of need to look under the hood at its engine, which is CI and CD. First up is continuous integration, or CI. Now, if you're in software, you know the absolute nightmare of merge hell. That's when you try to combine a month's worth of independent code from a dozen different developers at the very last minute. It's awful. CI solves this by automatically integrating changes into a shared repository multiple times a day. Jenkins is basically sitting there watching for these changes, and when it sees one, it builds the code and tests it immediately. It catches bugs incredibly early in the process. Then we have continuous delivery, or CD, which takes that whole process a vital step further. Once the code is tested, CD ensures that the software is always, and I mean always, in a reliably releasable state. It's honestly fascinating because Jenkins just hums along and automates this entire pipeline completely behind the scenes. From the exact moment code is integrated, all the way to the moment it's deployed, it makes sure teams are always ready to deliver high-quality software quickly, safely, and literally at a moment's notice. Section 3. The Jenkins workflow. Let's move to and see how this builds. So what does this actually look like in practice? Think of it like a highly efficient factory assembly line. Stage 1 is the code commit. This is where developers push their new code to a version control system, like Git. Boom, Stage 2, Jenkins instantly detects this commit and triggers an automated build. Then we move to Stage 3, testing. Jenkins runs a suite of automated tests to make absolutely sure this new code hasn't broken any existing features. If it passes, great, we hit Stage 4, artifact storage, where that successful build is safely packed away. Stage 5 is deployment, where Jenkins pushes the application out to a staging environment or even straight to production. And finally, Stage 6 is the feedback loop. If literally any of those previous stages fail, developers get immediate alerts so they can fix the issue right then and there. Section 4. Why Jenkins dominates. So why has Jenkins remained the absolute king of the hill for nearly 2 decades now? Well, now what's really interesting about this slide is that staggering number, over 1,500. That represents the massive, constantly growing library of plugins currently available for it. Extensibility is, without a doubt, Jenkins' absolute superpower. Because it's open source, the community has built a plugin to integrate Jenkins with practically every single tool in the tech ecosystem. Whether you need to pull code from Git, build it out with Maven, or deploy it across AWS, Google Cloud, or Azure, there is a plugin for it. It bends to fit your exact workflow, rather than forcing you to change how you work. And beyond just having a ton of plugins, the core advantages of Jenkins translate directly into real human benefits. By automating all those tedious, repetitive tasks, it offers massive speed and efficiency gains. Teams are spending way less time managing deployments and way more time actually building cool stuff. Plus, that early bug detection we talked about, it dramatically reduces the massive headache and the cost of fixing broken code late in the game. It also acts as a single source of truth, which really enhances collaboration, because everyone on the team can see the build logs and deployment status. And of course, being open source means you have total 100% control and customization over your entire pipeline. Now, to be fair, Jenkins isn't the only player in town, right? You might be familiar with other really fantastic CI/CD tools out there, like Travis CI or Circle CI, which honestly offer very similar, very powerful functionalities. However, Jenkins differentiates itself through that unmatched open source flexibility. While some of those other tools might be a little bit easier to set up right out of the box, Jenkins provides a level of deep customization and robust community-driven support that is incredibly difficult to outgrow, literally no matter how complex your operations end up becoming.
Section 5, Challenges to Consider.
So the crucial point is, a tool this powerful definitely isn't without its trade-offs. Because Jenkins is just so flexible, setting it up initially can be undeniably complex, especially for beginners. It is absolutely not a set it and forget it kind of tool. It requires careful configuration and pretty regular ongoing maintenance to keep it running optimally. But on the bright side, the actual system requirements are surprisingly lightweight. It runs on literally any platform that supports Java. For a basic setup, you really only need a server with about 1 GB of RAM and a multi-core CPU. Though obviously that's going to scale up depending on how crazy your build complexity gets.
Another massive consideration is security. I mean, think about it. This server literally holds the keys to your production environments. That's a big deal. But despite the maintenance required, Jenkins takes security incredibly seriously. It features a really robust security model right out of the box. We're talking strict user authentication, proper authorization protocols, and fully encrypted communications. Plus, because the open source community behind it is so massive and so vigilant, security patches and updates are pushed out incredibly fast to make sure your automated pipelines stay locked down.
Section 6. The future of automation.
Looking forward, Jenkins just continues to prove its adaptability, scaling effortlessly from small, nimble startups all the way up to massive global enterprises. The bridge between writing a piece of code and actually delivering it into the hands of users has been fundamentally transformed. Jenkins shows us that by letting machines handle the heavy lifting, human teams can finally focus on what they do best: creativity and innovation. So I'll leave you with this thought to ponder. As software development continues to evolve at this breakneck pace, how will automation reshape your own workflow? What manual, tedious tasks are you still doing today that a tool like Jenkins could easily be doing for you tomorrow? Thank you so much for joining me for this explainer, and keep exploring.